two theorems that have mystified college students for years and years are Rolle's theorem and the mean value theorem. So we're going to unpack these theorems and see how and why they can be useful. So first, let's start with Rolle's theorem. The reason we start with Rolle's theorem is because it's used to prove in the proof of the mean value theorem. So theoretically, it is the background to the mean value theorem. So here is Rolle's theorem. Let f be defined and continuous on a closed interval AB, remembering that means it's continuous on the open interval and continuous from the right and the left on the endpoints, and differentiable on the open interval AB, meaning we can take the derivative at any point except the endpoints. So suppose we have zeros of our function at A and B. So the interval we're talking about AB is between two zeros. So f of A equals f of B equals 0. Rolle's theorem says that this means that f prime of C equals 0 for at least one C in the interval AB. Okay, so what that means is that we have to have a place, there has to be at least one place with a derivative of 0. Okay, it's possible to have more than one. So let's illustrate this. So we have a continuous function on A and B, and so it says at least one C. So let's say our function does this. So we would have a point here. This could be a C1, C2, and C3. So at least one point, but it could be possibly more than one, that has f prime of C, or the derivative of f of C, equals 0. So what can we do? What can we use this for? We can use it to prove that there isn't a root of a specific function. So example number 1. Prove that x cubed plus 2x minus 3 equals 0 has exactly one real root. Okay, so here is the Precalc 12 way of doing it. We would check. Let's use we have 3, so the rational root theorem says that we need to have the only possible roots are plus minus 1, plus minus 3. Those are the only possible rational roots we have. So let's try 1. So 1 cubed plus 2 times 1 is 3, minus 3 is 0. Okay, so 1 cubed plus 1 minus 3 equals 0. 1 is a root. So we would then do our polynomial long division, or more simply our synthetic division. 1, don't forget the 0, 2 minus 3. Okay, and so 1 times, bring down the 1 times 1 is 1, plus 1 is 1, 1 times 1 is 1, 2 plus 1 is 3, 1 times 3 is 3, which gives us a 0. So that means we have x minus 1 times x squared plus 3, x squared plus x plus 3 is equal to 0. So now we have a quadratic equation, so we can plug this into the quadratic formula. This is our root at x equals 1. So we'll try to solve here. X equals -1 plus or minus the square root of 1 minus 4 times 1 times 3 all over 2. This is going to be a does not exist, so that means the equation has exactly one real root. Okay. So here is the Rolle's theorem way. Okay. So we go through the process and try x equals 1. So let f of x equal x cubed plus 2x minus 3. Okay, let's say we have tried, so we try x equals 1. Okay, but we don't know synthetic division, polynomial long division. Okay, try x equals 1. 1 is a root. Okay, so let's let a equal 1. Okay, assume there exists a b such that okay, such that f of b equals 0. So we're going to try to apply Rolle's theorem here. So assume there is a second, a is 1, assume there is a second root somewhere. We don't know what b is exactly, but let's assume it exists. So in order to use Rolle's theorem, we need to pay the ticket. We need to make sure that we check to make sure the initial conditions of the theorem are met. So f of x is a polynomial. Therefore, it is defined, continuous, and differentiable on negative infinity, infinity. So it's defined, continuous, and differentiable everywhere. So if we section off AB, it will fit the precursors of Rolle's theorems, the thing that must be true. So by Rolle's theorem, there exists a C such that f prime of C equals 0 on the interval a, b. Okay, so f prime of C equals 3c squared plus 2. So we take the derivative, we get 3c squared plus 2. So we'll set that equal to 0. We get 0 equals 3c squared plus 2. So negative 2 equals 3c squared. But this cannot be. Oh no! So we have what we call a contradiction. Okay, so this can't happen. We can't have a C. Therefore, our assumption, so we made an assumption, and our assumption that we made was assume there exists a B, such that f of b equals 0. That B, such that f of b equals 0, cannot be true. And we have a contradiction. So what that means is the opposite of what we assumed has to be true. We assumed there is a B, therefore such a B cannot exist. Okay, so such a B can't exist, and f of x has only one real root. And as a side note, this form of proof is called proof by contradiction, which is where you assume the opposite of what you want to prove and then show that that leads to such disasters as 3c squared being equal to minus 2 or some other mathematical statement that simply can't exist. And we call that the contradiction, which means we have contradicted our original assumption that must be true.